So welcome to the next lesson in the series on structure and bonding, and it's a lesson on how to draw Lewis diagrams, which are a representation of the structure and bonding of simple molecular compounds. Named after Gilbert Newton Lewis, the famous chemist who used these and developed these diagrams. So what do these guys show? Well, Lewis diagrams can give us a representation of how atoms combine, so that each atom has that stable outer shell. The outer shell has either 8 or, for hydrogen, 2 electrons in its outer shell. It's nice and happy and stable. They only show outer valence electrons as they are the electrons involved in the chemistry and in the bonding. So these are the Lewis dot diagrams for the elements. So for example, hydrogen with 1 electron, you see the 1 electron dot. Okay, and lithium, again, 1 electron because the outer shell only has 1 electron. Conversely, for group 8, you notice that they all have 8 outer electrons, except for helium, which has 2. And for group 7, again, 7 outer electrons. Notice the group number correlates to the number of electrons, in the outer shell. Okay. So now we're going to work through a series of steps of how you would create a Lewis dot diagram. And we're going to be using the compound sulfur dioxide as our example. The first step that you would have to do would be calculating the number of valence electrons in SO2 or sulfur dioxide. So sulfur, from our previous diagram of the atoms, has 6 valence electrons, and oxygen also has 6 valence electrons, because they are in group 6. And therefore the number of valence electrons is going to be 6 plus 2 times 6, because remember there's 2 oxygen atoms, giving a total of 18 valence electrons. In step 2, you draw the atoms and add 2 bonding electrons. This is the single bond. Remember, a single bond requires 2 electrons to be shared in covalent bonding. Remember, the central atom is usually the one with the lowest electronegativity. We haven't really gone into electronegativity yet, but just consider it the one that's furthest away from fluorine, because fluorine has the highest electronegativity. So here it is. You've got oxygen and sulfur in the middle, because it's the central atom is the one with the lowest electronegativity. Sulfur is furthest away from fluorine. And you put your 2 bonding electrons in. So the next step, step 3, is to fill the valence shell of the outer atoms. Okay, so we know that the outer atoms are going to have 6 outer electrons. We've already got 4. Okay, so it's going to give 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, however, we need 18 valence electrons, so 18 minus 16 is 2 electrons. We still require 2 more electrons to be placed on the molecule. So you place the remaining electrons around the central atom. 1, 2. Because 2 minus 2 equals 0 electrons. So you begin then, once you've got this down, do it in pencil, move pairs of electrons to fill the valence shells of all the atoms. Okay, so we can move the oxygen around, so that means you end up with a double bond between sulfur and oxygen there. And you've got a single bond when it's sharing 2 electrons, and a double bond when it's sharing 4 electrons. Okay, so you can now see you've got 1, 2, 3, 4, 5, 6, 7, 8 around the oxygen, 1, 2, 3, 4, 5, 6, 7, 8 around the sulfur, and again 8 around the second oxygen. So far so good. So how do you know which atom is central? It is usually the first atom in the compound. So for our sulfur dioxide example, it was sulfur. Or using the rule of if the compound contains only H, O, N, or C, or hydrogen, oxygen, nitrogen, or carbon, carbon will be the central atom over nitrogen, oxygen, and hydrogen. Nitrogen will be central over oxygen and hydrogen, and oxygen will be central over hydrogen, which you see in water. If a compound has a formula of 2xy, then Y will be the central atom, as in the case, again, like water. The least electronegative atom is put in the middle. So tricks of the trade. This year we'll be dealing mainly with atoms that need either 2 electrons on the outer shell, like hydrogen, or 8 electrons on the outer shell, like most others, except helium. There are 2 exceptions: the molecules that contain boron, which has 6 in total, and the example being boron trifluoride, and beryllium, which has to have 4 in its outer shell. That's one of the things about chemistry, there's always an exception. Okay, so your task is to fill in this, copy and complete the sentences, and that should be the end of the lesson. But remember also to give an example of the compound that has one of these.